Okay, we're on the next section of the spring semester exam review for Algebra 1. It says, write each expression in exponential form. This is kind of the opposite of what we just did in the last video. The last video, it was in exponential form, and we took it to radical form. Now it's written in radical form. You see all these radicals. We're going to pick up the tree and write that most of those exponents, at least starting out, will be a fraction now. So when I pick up this tree, the 4 goes up way high on top, the 3 stays where it is, right? You can imagine that 4 here on the right getting picked up, and now the 4 is on top, the 3 is on bottom. That's how you do this. So we end up with x to the 4/3 power. And that's it. That is the same, that's the answer to number 20. X to the 4/3 power. Number 21, we have 3x all raised to the 4th power. Now remember, if there's not a number out here for the root, it's automatically a 2. So we raise up that 4 to the top, and we have 3x all to the 4/2 power, the 4/2 power. Now what is 4 divided by 2? It's 2, right? So really it's 3x squared. It's all squared, right? Now we can square the 3, it's a number. 3 times 3 is 9. So we end up with 9x squared when we're all said and done. Number 22, we have 125, the cube root of 125x to the 4th. Now notice, this 4th is not touching the 25, it's not in parentheses, right? So we're going to have to write this a little bit differently. The exponent on the 125 is a 1, the exponent on the x is a 4. So I have 125 to the 1/3 power, but we don't even have to do that, because if you think about it, that number we can put in the calculator. If I ignore the x to the 4th, this entire part can go in the calculator. So in the calculator, I'm going to type in cube root of 125. So control caret, cube root of 125. Oh, that gives me 5. So that made that part be pretty easy. Now all we have to do with our picking up the tree, it's just for the x variable. The 4 goes up to the top, so we have x to the 4/3 power. So our answer for number 22 is 5x to the 4/3 power. Okay, number 23, square root of 49x. Again, we can do the square root of 49 part in the calculator. Square root, I did control x squared to get the square root button. 49, most of you may know it's going to be 7, right? So we have 7 square root of x. Now how do we, remember, we don't want to write 7 square root of x, we want to write this in exponential form. So what numbers are here? Well, there's an invisible 2 here, there's an invisible 1 here for the x. We pick up that tree, and we end up with 7x to the power of 1/2 for that one. All right, that is number 23. So let's take a look at the next one. Next section, we're going to simplify each radical expression. So we have, and this is all calculator again, most of it is. We have square root of 180. Actually, I'll take it back. It's not, only if it's a perfect square is it all calculator. But we can do some of this. We'll try by doing the square root and see what we get. See how that comes out messy, right? So we can't do this all in the calculator. But what we can do, I'm going to remind you of how to get the factors of a number. So I'm going to put in the 180. Actually, I'm not yet. I'm going to go to my menu. And when I go under the number option, I have this option here, factor. I want to factor 180. It breaks that up into the building block numbers that all multiply together. I have 2 squared times 3 squared times 5. So what I can do is I can write this in place of the 180. Okay, so I have square root of 180. That is 2 squared times 3 squared times 5. Now what I can do with that, since it's a square root, it's like playing the Go Fish game. That's how we taught it earlier in the year. Since it's square root, every 2 of something on the inside gives me 1 on the outside. Okay? So I mark this out. I have a 2 on the outside. I mark this out. I have a 3 on the outside. I'm going to multiply those numbers together. I don't have 2 5s. I have to leave the 5 on the inside. So I end up with this. 2 times 3 is 6. So my final answer is 6 square root of 5 for number 24. For number 25, I have the square root of 16 over 100. Well, the first thing you do on that one is you rewrite it as square root of 16 over square root of 100. And the good news about that is those are both perfect squares. But even if you don't know that they are, which you may not, go ahead and do your factor button again. So I'm going to go to Menu, Number. I'm going to factor 16. 16 is just 4 2's, right? 2 to the 4th power. So I'm going to say it's the square root of 2 to the 4th power. Remember, for every 2 on the inside, I can take 1 on the outside. Well, I have 2 to the 4th power is 4 2's multiplied together. So those give me 1 on the outside, and those give me another 1 on the outside. All that to say, the square root of 16 is 4. 2 times 2. Right? And you could do the same thing with this one, but a lot of you know that 10 times 10 is 100. So the square root of 100 is 10. So you end up with, after all that, 4 over 10, no more radical needed. And you can reduce that a little further. 4 tenths reduces to 2 fifths. That's that one. Okay, let's take a look at number 26. We have 5 square root of 99. Let's go ahead and see what we can get out of 99. Let's go ahead and go to Menu 2, 3. Let's see what we can get with 99. We have a pair of 3's and an 11. So what I have, I'm going to get rid of my old work so it doesn't confuse you guys. What I have 5 on the outside, but that square root of 99 I rewrite as a pair of 3's and an 11. 3 times 3 times 11. That pair of 3's becomes 1 3 on the outside. And that 11 has to stay. So what I have is 5 times 3 gives me 15. And then inside the radical I have 11. So 15 square root of 11. And this last one, the square root of x squared. Now we can't put it in the calculator, but it's actually really easy without the calculator. X squared means you have x times x. Remember, for every 2 on the inside, when it's a square root, you have 1 on the outside. So what is the square root of x squared? It's just x. Okay, that's that section. We will do the next section on the next video.